Today we mainly bring Xiao Zhi AI and ATTSRE's operating system, the integration project. We will introduce it in several aspects next. First, our background, technical details, and overview. It also includes Xiao Zhi's future expansion projects and summary. First, the background part. We will watch a video, which is about. Recently, Xiao Zhi's open source author Xiao Zhi recorded a practical video.
你好，小智。
虾哥好呀，今天写代码又写到忘我境界了吗？
把屏幕调成暗色。
好嘞，这就帮你调暗屏幕。
你是什么模型呀？
人家是 DeepSeek 模型啦。虾哥，你今天写代码写糊涂喽。
我今天给你装了眼睛，你看一下我长什么样子。
哇塞，虾哥给我装摄像头了，让我看看你这个码农帅不帅？哇哦，虾哥今天穿灰色衣服超帅的，眼镜配凌乱头发，很有码农 style。下次记得把头发梳一梳啦。
好的，我今天都没出门，不用梳头发。
虾哥，你484宅到连头发都懒得梳，不过在家写代码确实舒服。
来，你看一下这个是什么？
虾哥又给我看什么好东西啦？让我瞅瞅。虾哥，你484感冒了才买这么高级的面巾纸，这个紫色包装超有质感的。
这是什么牌子的呀？
虾哥，你484故意考我，包装上明明写着 Members Mark 啦，美国山姆会员店的高端货耶。
我再考你一个高难度的，你再看一下这个是什么呀？
又来，虾哥，你今天是在玩猜谜游戏吗？让我看看这次是什么神奇宝贝。我靠，虾哥，你连汉西斯都掏出来了，是要修电路板还是 DIY 机器人啊？
看你还挺厉害的，这你都知道。
那当然啦，我可是虾哥亲手调教出来的 AI， 连汉西斯都不认识的话，岂不是要被你笑死
The video, we can see that Xiao Zhi is a multifunctional intelligent terminal that includes image recognition, voice recognition, and can output different voice tones, etc. A multifunctional intelligent terminal. Xiao Zhi's applications are also very broad, applicable to smart homes, IoT, and other scenarios. Additionally, the Xiao Zhi project supports MIT license, which means it can be freely open for use. The purpose of this open use is to help more people get zero-based access to AI hardware development, understand how to apply large models to actual AI hardware. At the same time, it is also an open-source intelligent device system, supports multiple functions, including voice interaction, graphics, graphical interfaces, and flexible devices, communication display frameworks, etc. Next is about Xiao Zhi's core technology overview. In core technology, first is this. We use OPUS for encoding technology. This efficient audio encoding technology can compress PCM data while achieving low bandwidth and high quality transmission. In this case, in the context of network environments, supports high-speed rates. In terms of audio, we use PCM, which is postcode modulation technology, can convert analog signals we hear into digital signals, thus enabling transmission. Through PCM technology, we can record audio data. This is a block diagram of encoding. The first step is ADC sound collection. After sound collection, it goes through signal processing, then through encoding for transmission, finally. Then the transmitted data is played back through DAC. In terms of transmission, supports multiple connection modes. First, this web connection technology is real-time communication protocol used to transmit audio and status information, etc. through WebSocket sending. OPUS data receiver processes and returns status and audio. Has encryption, security features, and is suitable for high-frequency interaction scenarios. Additionally, Xiao Zhi supports MQTT, subscription protocol, mainly used for controlling IoT devices. For example, it can control turning on lights, etc. This is commonly used in smart homes. A feature. It also has low power consumption and low bandwidth characteristics, making it very suitable for IoT control scenarios. In terms of display, it uses LVGL technology. LVGL technology is a lightweight embedded display UI. It can display device status, information, connection status, and command feedback, etc., which was also demonstrated in the previous video. Next, we'll discuss the details of the core technology. Details of the core technology include functionality, function and application. Xiao Zhi can support compressing PCM data into low bandwidth. OPU data for transmission. Then send through the two web protocols and MQTT protocol we mentioned earlier. Finally achieving low latency and high quality audio transmission. The advantages are: in terms of network transmission, regardless of the network environment being good or bad, the transmission speed requirements can be met. Next is the overall project process flow diagram. First, initialize the money. It is in an on state, and after initialization, it is set to studying state. At this time, a step of configuring Wi-Fi is needed. Because Xiao Zhi needs to connect to the cloud for AI backend data processing, this step is essential. So, we mark it as this Wi-Fi config state. Then, after connecting to Wi-Fi, activate the device to enter the Xiao state. At this time, it will detect automatically whether there is a new version, which is what we call OTA. When there is a new version, Xiao Zhi will also perform an OTA. When activation is complete, move to the next state, which is what we can see at the application layer. The state ready to start a conversation. At this point, when we start the conversation, we will enter this listening state, which means the user is speaking. After entering the lining state, Xiao Zhi will upload the data it has collected to the cloud for sum. After processing, it enters the speaking state, which means Xiao Zhi transmits outward through the speaker the data just processed. In the drawing flowchart, the first step is establishing a web connection at this time. This is the first step of the connection, which involves uploading a message to describe the current status, after passing through OTA or successful connection steps. It will enter the next step, which is transmitting this hello message state. The specific content of hello message will be mentioned later. Then, after passing through this hello message state, enter the next step, which is the beginning of the voice interaction loop. The voice interaction loop consists of multiple states, starting with sending and beginning to listen for audio data transmission. Receiving and recognizing the results. The recognition results are information returned from the cloud, and additionally, the information returned from the cloud includes TTS audio data. When ending the conversation, the connection will automatically close, which is roughly our network connection flowchart. During the connection, the form of the message includes the following parts. First, assess token, which is the key we hold. The key we hold is a critical key for connecting to the AI backend. At this time, it includes internal version information and local hardware's MAC address and the device UUID for this conversation. Then the initial message sends these basic information to the backend. The backend will process it. If the connection is successful, the client will first send a hello message, which includes message status, message version, and transmission method. Among the transmission methods, There are agreed-upon protocols that play a crucial role in later audio transmission. We must first agree on bitrate and include channel 10. This way, later audio transmission and audio processing won't have issues. After the server receives a hello message, it responds with a hello message, which is the same as we align our hardware end. Its return is similar, starting with the message type. Then the message transmission method, which is the protocol the message uses. It also includes some detailed audio parameters. These parameters must be pre-specified during later audio processing. Then entering this listening listening state, the listening state will also generate a report. And this leopard pattern, similar to before, some key information, such as the ID of this conversation and the current status, and the hardware's current status. Also includes the current mode. These are some of the states, starting with the STA, listening state. Listening state. It also includes paused listening, which is when interrupted. Ending the conversation. The message sent by Sure. Notice how it has become a stop. This is the key to our interactive information exchange, the state transfer. When the server sends TT data, the message is as follows. The TTS data mainly includes the content of the audio to be played next, including a test, which is the text information. These are the text information, which are the content of the audio to be played next. On the web protocol, the upper layer transmits JSON, JSON text, and binary audio frames. This audio frame is what we've been discussing, the encrypted audio dispute machine, an audio frame after the bit rate. The completed functions also include audio stream transmission, PTS audio left to play locally, language recognition, IoT commands, etc. Its core can be divided into 3 parts. First is the handshake phase. Send hello message, wait for the server's response. Once the handshake phase is established, enter the audio channel. Then transmit the binary bidirectional voice stream data encoded by OPU. Among them, after the voice stream transmission ends, transmitting this JSON format data. JSON format data mainly includes using the type field, which is here, display type field. This mainly represents the status of the current device. Additionally, Xiao Zhi has many other features that can be developed. This included the display function, which is what we just discussed, the LVGL interface IC. It can not only display the current emotional state of the character, but also the playback status, and it also supports music playback, etc. This is a feature that can be expanded in the future. At the same time, Xiao Zhi currently supports multiple languages. Model, it passed. Sense voice. In the backend, process the transmitted language. Currently, Xiao Zhi can already support including Mandarin, Cantonese, English, Japanese, Korean, etc. 5 languages. Additionally, Xiao Zhi's application scenarios are also very broad. Here, we can watch a video to see Xiao Zhi's application in smart home technology.
Turn on the lights in the dining room and living room. Playing JTEL songs in the living room. Playing J-Chow songs in the karaoke bar.
正在播放周杰伦的音乐。
Let's change to a song by Ah Sang.
正在播放阿桑的音乐。
Let's change to a song by Mayday.
正在播放五月天的音乐。
Set the ceiling light in the living room to the lowest setting.
客厅的吸顶灯已经调到最暗，这样听五月天是不是更有氛围一点？还需要调整程度。
Living room. Open the living room curtains.
客厅的窗帘已经打开了，现在这样光线和音乐搭配的怎么样？
The living room. The living room music paused. Living room music.
客厅的音乐已经暂停了，需要我做点别的吗？
The living room music continued.
客厅的音乐继续播放吧，享受你的音乐时间吧。还有啥需要帮忙的？
The sound of the living room music is too loud.
好的，已经把客厅音乐的声音调小了一些，这样听起来舒服点了吗？如果还需要调整，告诉我。
Through the video, we can see that Xiao Zhi can correct based on the MQTT protocol. The hardware devices inside the house are managed in a mode where commands are issued through the backend. It can achieve the application of a smart home internet scenario. In addition, Xiao Zhi has many other scenarios to expand in the future, including smart health management, for example, able to remind users to take their medication on time, monitor sleep, etc., as well as smart security, able to identify the camera at the entrance and the live broadcast of the camera feed. In addition, there are applications in various scenarios such as smart agriculture and smart transportation. The application scenarios are very broad. At the same time, Xiao Zhi supports multiple hardware platforms. This allows it to run on different types of hardware platforms, meeting the needs of different users, which is also the RTSR operating system. The result of integration. In the future, Xiao Zhi has several core advantages. Firstly, it is fast audio processing and flexible connection modes, supporting multiple connection modes, along with a lightweight UI interface. In IoT integration, IoT scenarios, etc., multiple applications. WeRT will soon launch a development board equipped with Xiao Zhi's intelligent agent. Look forward to it.